So hi, my name's Aaron, and so I'll be your instructor for this session. I guess the package that we'll be going through today, the three packages are very useful because I'm a graduate in statistics and I'm a statistician for like a biofarm consulting company. So I analyze a lot of data every day pretty much, and these three packages I almost use them every day. So if you can, I wouldn't say master, but at least you can understand how to use them, it will be very useful because you can almost deal with any kind of data manipulation, subsetting, summarizing, whatever table. You can pretty much do almost anything if you can, if you know how to use these three packages. Today we're gonna use the generic data set empty cars from the R in R. So first, I guess to load the data, you just type data bracket and then empty cars. And once you have that, you can type it in console or you can just run it in the script. So once you do that, you click enter, and it shows promise, but once you say, if you type it, it will come, there we go. So now it's in your environment. So you can, if you have RStudio, I assume you probably everyone use that, you can see the data set like you do in Excel. So I guess that's one good benefit of RStudio. I also found like the column names from online where it describe what each column means, because sometimes when they just say DRAT, you might not know what it actually means. So here it actually means real axle ratio. And another time is when you have weight, you want to know the units. So here weight, it's actually 1,000 pounds. So the weight here is 2.6, that means 2,600 pounds. So once you have the data, okay. So I guess the first most commonly used function in dplyr, we'll start with dplyrs first, and then we'll go to magrittr, and then the tidyr. Because once you learn how to use the function in dplyr, then you can apply the piping notation to all those functions. Will make your code not only easier to read and also easier to type too. So when we go to, so usually the most common function is a filter in dplyr. So a lot of times when you have a data set like here, you only want a subset. You don't want, so here each row it's a type of car, and each column it's the specs of the car. So oftentimes you don't want to analyze all the cars. So for example, when we look at the column AM, for example, AM is transmission, whether it's automatic or manual, right? And if you're only interested in automatic, so you're only interested in cars that has value 0 for AM. So in that case, you want to filter out the cars that have manual transmission. So you can see, you can click here to sort them. So you're only interested in these cars with zeros for AM. So then you will need to use the filter function. So I will delete this actually. So filter out all manual transmission cars. AM equal to 0. So well, the function is just called filter, and the first argument is you're going to type the data set you have. So in this case is the empty cars, and then whatever set, and then you put a comma to indicate that that's your data set. And then since you want column AM to be 0, so you do AM equal to 0. So remember, or just a note that in R when you want to say something has the value of something, you use double equal sign, because the equal sign is strictly for assigning value to a variable. So let's call this data1. So let's first. So once you have this, so you want to filter out only to you only want automatic cars. So if you do this, you get a long list, which usually is not what you want because it's hard to see this way. So usually what I would do is I give it a new name. So call it data1, so that it will be in your environment and it's easier to refer to if you want to do more analysis. So now you do, yeah, so you call it, or I call it dat1, and I filter out all the manual transmission cars. So now you can see it in the environment, dat1. Here you see it's only cars that has automatic transmission. So that's how you would use filter. And any question so far? Oh. So and of course, sometimes obviously you want to subset or filter out multiple filter out multiple I guess specs in this scenario. So I guess here we did the transmission, and and also I guess you're only interested in maybe what's VS, let's forget, engine, so V shape or straight. Okay, so suppose you're only interested in automatic V shaped cars. So in that case, not only you need to filter out the zero, what we did here, but we also need to filter out the VS column to set it equal to 0, right? So you need to filter it 2 times. So the benefit of filtering the filter function in dplyr is that you can enter everything in one bracket, whereas if you do it in the generic base R filtering command, it gets kind of messy. So now you want to filter out all manual transmission. I guess I'll type it in. Filter out all cars with straight engine. All cars straight engine, i.e. VS equals to 0. We need to do these 2 filtering. 2 filters, I guess. So first one is just the same as before. We don't have to change. And if you want to add another conditions, all you have to do is just type comma and then the second condition, and then you're good to go. So it will be like this. So this. So now I'm going to call this dat2. So you type it in console, or you can run it in script, whatever you prefer. Run it, and now boom. So here are the new data set with AM equal to 0, automatic transmission, and then VS equal to 0, V-shaped engine. And you can, yeah, so doing it this way, like if you want to add and keep adding more filters, you can just keep adding comma, blah, 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 condition, and then you can get the subset that you want. Keep everything but whatever AM you want to use. So what if you want to keep everything but the rows that AM is 0? Oh, okay. So you want AM equals to 1, right? Is that? Yeah, not equal. Yeah, exactly. Or we will get into that in the magrittr package. There's actually a very useful I don't know what's called function. I wouldn't call it function, but like a operator. Yes, that allows you to subset. For example, in cylinder, for example. So in cylinder, there's 4, 6, and 8. So if you want 6 and 8, obviously you can do 4 equals to 4 or equals to 6. Let's do that actually. So I want here filter out cars with 4 cylinders, i.e. we want cyl equals to 4, 6, or 8 equals to 6. So yeah, like again, oftentimes you'll have variable or columns that have multiple categories. So this is one. So what you can do is again, obviously you go back to the filter function and you go to cyl, cyl. You want it equal to 6, right? And then but this is not, if I do this, let's see what we'll get, okay? So you actually get nothing. Because when you do this, you're saying you want cars that have 6-cylinder and 8 cylinders, which you don't have to. You can just use a different, you can just do this, I think. Yeah, the or, I think. Yes, there we go. So instead of a comma, you put this straight vertical line. It's above the enter, that straight line. So this will give you, this is the or. So or operator, I guess you can call it. So negative. So oh yeah, you can do this, like not equal to 4, right? Yeah. So you can do so not equal. So in RS, exclamation equal. Yeah, this is another way of doing it too. So yeah, that's good. I mean, that's a good idea too, because sometimes you don't want to type too many things. So here you only have to type one condition. So yeah, so these are the two ways you can filter out all the cars with 4 cylinders and include cars with 6 or 8 cylinders. Cylinder equals to 6 or 8. So any questions? Yeah. That's I was gonna get to that when we start the because yes, like so that's the other method I was mentioning. It's very useful operator in the magrittr package that lets you filter out a bunch of stuff at the same time, so you don't have to type in cyl equals 6, cyl equal to 8, cyl equal to 10 if you have multiple cylinders, different cylinders, right? So again, these two package makes your code a lot easier and shorter and cleaner, and that's why they're very useful. Yeah. So I guess we're good with filter. Oh, filter, right? Okay, so filter, it's you subset the data by rows. You take out the rows right here. We take out the rows that had AM equals to 1 or AM equal VS equal to 1. So next, we'll look at select. So select is you take out the subset by taking out columns, and usually I guess when I use select, it's because I want to do other subsequent analysis that does not require all the columns, so it will reduce the size of the data set. And but, I mean, obviously there are other purpose for this, but that's for mine in general. And sometimes you have, or I guess, yeah, we'll get to it later. So select, again, it's if we want to select, so when you select like the columns that you're interested in. So I guess we can horsepower, excuse me. So HP is the horsepower, and the Qsec it's the time it takes to go a quarter mile in a second. So what I would do is select only the HP, the horsepower, and Qsec mile columns. So call this data 5. So you do select, and then the first argument again is the empty car, or sorry, your data set. So whatever the name you named it, and then afterwards you just type in the columns that you're interested. So HP and Qsec. So when you do in note that when we do these, we didn't have to add the quotation mark to make it whether when we use the function, but in select you can do it both way actually. So if I just do it, so because I'm interested in HP and Qsec, I can do this. So now that 5 only has 2 columns, right? Sometimes you can also, or not sometimes, but you can also enter it as a string or put like a quotation mark on it, and that will still work, or a mix of both, but it's not recommended to do that. So you can enter it with as a string, because sometimes maybe from other source you have a bunch of strings and you don't want to remove the quotation mark for all of them, right? So you just want to call them. So like, for example, if I call it call, so I named it, so I create a vector named HP and Qsec. So maybe you got this from another source and you just want to select these 2 columns based on select the column based on this whatever is in here. So you can also do that. So it will allows you to put in functions, or so this way you get the same thing. So that's the convenience, sort of, I guess you want to call that allows you to enter the columns that you're interested differently. So so now I selected these 2 columns. So the reason why I want to select these 2 columns, I just want to, I guess, make a plot. I mean, so that is very weird. So the reason why I selected these 2 columns is I wanted to make a sort of like scatter plot. I mean, what? Oh, oops. What just happened? Okay. I guess. Never seen that before. But I just want to plot, or just wanted to see, I guess, the relationship between horsepower and the time it takes to go a quarter mile. And I guess the more power you have for your car, obviously it takes less time to go a quarter mile. So I just picked these just to show as an example. So, and again, that matches my, I guess, assumption that the more horsepower you have, the less time in seconds it takes to go a quarter mile. So I guess if you have not used the plot function, it's very straightforward. It's just plot, and then you have to, or you don't usually have to, but I like to specify what, usually the first argument is x, the second is the y axis, but I like to specify them. So in the first axis, I specify it to be, in the x-axis, sorry, I specify it to be the horsepower in this data set. And then the y-axis, I specify it to be the time to go a quarter mile in the DAT6 data set. So I'm assuming this will be the plot function. You're likely to use it often too if you use R for data analysis. Plot horsepower against time to go quarter mile. All right, so any questions? And I'm, you might notice the reason like I had a lot of stars and stuff like that here. So it's when you look at here, you can actually see the subsections. So it's actually pretty cool if you, especially you have a lot of code. So here, like filter, and then if you add a second star here, so you know it's like a subsection. So that's just a way to make it easier to find your code. In case, or you can even click here, and then you can also go, you can navigate to other sections. So yeah. Any questions? Oh, okay. So I'm going to remove this so it doesn't close my R again. Okay, so the third function that I find, or I use it all the time, is so to create new columns. So let's see, let's look at the data. Okay. So here, the weight, like I mentioned earlier, it's in pounds, right? So 1,000 pounds actually. So this is actually 2,600 pounds. But what if for some odd reason you want the weight in kg? So then you have to, you know, create a new column that will reflect that, right? So that's when mutate comes to play. And I guess it's the name of the function sort of matches its purpose. You're mutating, creating new columns. So create new column. So I already wrote it. So because I needed the conversion. So you want to create a new column that convert weight from pounds to kg, or 1,000 pounds to kg. And I guess this is the formula, or the conversion. Yes. So 1 pound is equal to 0.43 kg. So essentially, you just want to multiply this column WT by 0.4356 and multiply by 1,000. Or actually, no, you don't have to. So do you have to? Yes. And multiply by 1,000. Yes. So what you do is that 7 So you mutate again, first argument, the data set, and then after you put a comma, and then you have to specify what you want to call your new column. So WTKG, that's a very clear description of what the column is. So, and then you put equal sign. So again, like I said earlier, when you in the filtering argument, when you want to say cylinder equal to 6, then you put the 2 equal sign. You don't put 1, because in R, when you do 1 equal sign, you're assigning something to whatever it's on the left side of the equal sign. So here you're assigning whatever you write here to this column WTKG. And it's not this, but it's going to be, like we said earlier, it's going to be WT times 0.4365. Well, because I want it to be in actual kg, so I'm going to multiply by 1,000, because I want to convert the weight back to pounds instead of thousands of pounds first, right? So this times 1,000, convert the 2.6 from thousand of pounds to actual pounds, and then multiply by 0.43 to get the kg. So once you do that, put it in console, enter, boom. So now you have a new column here. You see, that's your new column. So that's how you would do it to create a new column. And like filtering, so obviously sometimes you're gonna have to create multiple columns. So I'm gonna use the QSEC. So the QSEC, it's a time to go quarter mile in seconds, I assume. So what if I want to convert into minutes, right? And I want to convert the weight at the same time. So we're going to convert QSEC from seconds to minutes to minutes. So I guess we know 1 minute has 60 seconds. So and I guess we also want to do the conversion for the weight too, right? So we'll do create new 2 columns at the same time. So like similar to what we did for filtering, you just need a comma and add in whatever new columns that you're creating. So I'm gonna, since the second, now this is gonna call qmin because it's a minute, right? So it's gonna be qsec divided by 60 because you want to convert the seconds into minute, right? So once you have that, and then you click put in console, enter, boom, the new data set. Now you have the weight in kilograms and the time to go quarter mile in minutes instead of seconds. All right, so any questions so far? No? It's good. Okay, so these 3 functions are the most common function that you'll probably use in the dplyr packages to do like data manipulation. So as you can see, like if you want to do apply multiple function, you want to select and then filter and then mutate, then you have to sort of have like 3 lines. So you want to have one, you're going to have one for mutate, and then you're going to do like whatever filter here, like this, and then you do another one, you select. So it gets kind of messy because you'll have to like change the name of the, so you want to select, so select or something, So you're gonna have like 3 lines, and then you have to rename them or something. So it can get messy if you're doing a lot of data manipulation. So that's where the magrittr package comes into place, because it has 3 operators, typing operators that are very useful, that will make your code looks a lot more cleaner. And I guess it will also, I guess you can automate stuff so that if you change the data set that you're reading, you don't have to change all the subsequent stuff that you did. Because so it's like, I guess here, if you fill, so for example here, if you do this and then you do some analysis on data 1, which only has auto transmission cars, but if you change the empty car data set, then you're gonna have to come back and change this like again. So so now we'll start now we'll start talk about the magrittr package. So the first one that I want to talk about, I guess that one should be the easiest, is the one that that gentleman mentioned earlier. So I guess so the in operator. So this operator is useful in the sense that, like what we had earlier. So you want cars that have 6 and 8 cylinders. So you can obviously do it this way or this way. But what if you have, like, I don't know, like 15 different categories? Then so you're gonna have 15. You're gonna have 15 conditions, right? And your code is gonna be really long. So with this in operator, it will make it slightly, I guess I would call it prettier or easier to read. So we'll use the same example again. Let's call this 9. I only want a car with 6 and 8 cylinders, right? So I guess, yeah, we're gonna do this. So with 4 cylinders. Okay, so again, we're gonna filter this. So here, filter first argument data, and then second argument is the condition that you want to filter. So the column that we're interested in is a cylinder, right? So cyl, and pretty straightforward because you only want cars with 6 and 8 cylinders. So you just do in, and then you have to create a vector. So a vector is just C and then bracket and then like this. And then you get the same results. So let's see. So if I do run, we go with that 9. So you see, it's only 4. Sorry, it's only 6 and 8 cylinder cars. And as you can see, I mean, if you have just 2 different categories, it's it won't make that much of a difference. But if you have like 10, 15, 50 or something, then it will save you a lot of time, because you might be able to get those, for example, cylinders from another data set, then it's already stored in a vector. So for example, I'm gonna create cyl. So you can do this too. So you're gonna call this cylinder of interest, and you can change this to CYL. So you can, sorry. So you can also do it this way. You don't have to type it manually. So you might be, so this CCL vector, you might be, for some projects, you might get that from a different source. You don't actually have to type them out manually. So if you do this, it's the same thing. You get the same data set. So yeah, cars with only 6 and 8 cylinders. Close these. So yeah, this this operator, the in operator, is very easy to understand. I assume. And also, yeah, so it makes the code look nicer too, because if you have more category, like I said, then it's going to look very messy. Questions? Like it works with other functions. Yeah, it works. It was just a comment that you can use it outside of the category. I am not too sure either, but I always thought that because the yeah. Okay. Yeah, because because the other operator has a similar looks, I guess. So I assume they're from the same package, and maybe not. Right, probably. Okay. Yeah. Yeah. But the in operator. Oh, good to know. Yeah. The percentage sign. It just like the percent brackets the word in so that it doesn't. Yeah. If you take out the here, then the in, because now you see it's in pink, so it's like when you write the for loop, that in, so it's gonna be different than if you then you put the percentage sign around it, so that R knows you're referring to a different in. Okay, so the next one, this is I guess one of the most useful things that I was mentioning earlier. So if you want to apply multiple subsetting and selecting and things like that to the data set, then this will make it easier, so that once you change your data set that you used, our subsequent function will be applying to that data set. So I guess use whatever we have done so far. So let me see. So we did what we did earlier was we only want automatic cars, but now suppose I'm interested in manual cars, and because usually, like, I guess race cars are manual or fast sports car. So I want to do the same plot that you saw, and what and filter out all the manual cars, and then I only want the column, the column that I created here, the Q min. I want it in minutes versus horsepower. So I guess when we write it out, it will be easier. So yeah. What you do is you use the cars. So what this the forward arrow, I guess, do is when you do this, whatever function that comes next, it's going to be applying to this data set. But of course, it depends on the function. At least within the tidy first, it will be usually, then it will be like the first, it will be always this was the data that's going to be used on those functions. But you can also use function that's not in tidy first. Then you have to specify which, I guess, argument it is the data set that that you're using. So first, oh yeah, I guess I want and also when you use this operator, it also makes documentation a lot easier too. I find it, at least. So only one manual cars. So AM equals to 0 or 1, sorry. So you set this AM equal to 1. So if we start with that, oh, oops, sorry. See, you need two equal sign. Once you run, then you go here, and then you look at AM. It's all 1, right? So it's the same as what we did here. So it's the same operation. Just if you change to 1, these two are the same, exactly the same. So once we filter out the manual transmission, then we wanted to create the qsec and convert that from seconds to minutes, right? So how did we do that? So we do the mutate. Oh, sorry. I should know that, like I said, before when you do the filter, you had to type the data set here, but now you don't need to. You can ignore that because filter, once you use this, filter knows that you're applying whatever you're filtering out based on this data set. So that's the advantage. You don't have to type empty car, keep typing them. So yeah, next, so oops. Convert qsec to minutes. So remember to create new column is mutate, and then we call that qmin equals to qsec divided by 60. So again, you see, I don't have to type the data set name, like the empty car here. I don't have to do this anymore. I just type the new column that I'm interested in creating. And once you do this, then so when you go to so there we go. So you have the qmin. And then next is select only the horsepower and the qmin because we're interested in the plot, right? So for HP and qmin. Okay, sorry, not mutate. Select HP and qmin. So you can do this, and then once you do that, and then you run it. Now, I suppose I'll keep the AM just to show so that AMs are 1. So now you have AM all the 1s and only the HP and the qmin columns. And this part, I believe you can also do, but I don't know, never used this before, but yeah. Oh, yes. Good catch. So in tidyr, the person that created the package, Hadley Wickham, he doesn't like row names, because he thinks that row name is just a column because you can move it to the columns, right? So whenever you apply any tidyr functions to a data frame that has column names, it will drop them. Yes, good catch. Sorry, I should mention that. So you see all these data set, the column names are gone. Whereas if you look at the initial, it has the name or the brand of the car, right? The model of the cars. So they're dropped like silently because it doesn't tell you that they dropped it. So so there's actually a function that lets you, I guess you can do it yourself too, but that create a new column and put it in the so it will put it in the first, put it before MPG, that move the column, the row names into a new column. So that function, so it's actually in this package in Tibble. So it's also one of the tidyr package. Tibble. That is a good point. I missed that. Move row names of empty cars to column car model. So what you can do is you row names to column, very straightforward. And then the argument, I believe you just have to type in the name. Always have to refer back to the manual, but I think this should be it. So let's look at if this is correct. So when you go here, so you see now I move the row name from initially it was here, right? The row names. Now it's a column in an actual column in the data set. I named it car model, but you can name it whatever you feel like. So yeah, that's a good point. So if you want to use tidy first package and you know that your data has a row name, have row names, then make sure you do this so that you don't lose that information. So now if I do this, oh, I should probably select the car model too. When I first started using like the tidy first thing, like all these, I actually went into the same problem. Like I'm used to like filtering stuff according to the row names, and then when I started using dplyrs, I went into some trouble initially because I didn't know that they dropped it, and then I was like, oh, where did the row name goes? And then when I read up on it, it says it's dropped silently. So so yeah, see, once you move the row names to a column, call this car model, and then you do all these subsequent I guess data filtering and selecting, then you arrive at this final data set with the name of the car, transmission, the horsepower, and the minute it takes to go a quarter mile. I think you can do this. I'm not sure, but I've seen it somewhere. But I never used this before. Usually I don't use this, but let's see if that works. T. Oh, T4 arrow. I don't know if that will work, but let's try this. Yeah, that's you can do that, but I was figuring to use it, but I guess it doesn't. So yeah, I guess we can do gplot. So another tidy first package is gplot 2. So it has a lot graphics that's a lot nicer than the base R graphics. All that. So because it's in tidy first, so you can it works with all these piping operators. So you do gplot and then GG hist no GG right it's not it's yeah no it's a scatter plot. It's I forgot which point. Yeah, point. Yes. But okay, so okay, let me explain what. Yeah. No, I assigned it to this data, but let me plot horsepower versus minute. So what I did was instead of using the base R plot function here, I used the ggplot, and again I did the same thing. I pretty much just do like a scatter plot with the x-axis being horsepower, and the y-axis being the minute it takes to go a quarter mile. And so now, before, if I don't add that initially, when you do data 10, you get a data frame, right? So, but if you add this plot, then now it actually become a plot. So if you call that, it's actually a plot. That's because I apply the ggplot function to the data frame. So I convert that whatever data frame I have into a plot. So now, and also as you can see, this graphic looks a lot nicer when you compare it to the base R. Where did it go? So this is initially the base R graphic, which is I don't like it. So, and then when you go to ggplot, looks a lot nicer. And of course, you can change the color and do a lot of things, but I think that's going to be covered in a different section, right? I assume. But yeah, so this is what, so you can see with this piping operator, or for piping, I guess, you can apply all these functions to this data set, and you don't have to keep creating new variables or things like that. Because if you do it like how we did it here, then you pretty much have to create a new line or create a new variable kind of thing each time. If you filter, you select, you mutate, and then when you do plot. So that's the I guess the big advantage of using this piping operator. I guess we have I just want to go over quickly one more operator. So it's just like a double arrow. So the double arrow, it's the same as if you want to say, if you want to do this. So for example, if you want to keep the name as empty cars, or this empty cars, I want to delete that. So empty cars 1 is equal to empty cars. So if you want to move the if you want to move the row names into column for this, you don't want to create a new data frame. Obviously you can do this. You just assigning empty car 1 back to empty car 1. But like, I guess I'm lazy, I don't want to type too much, then you can just do this. It's the same thing. You're saying, okay, I'm doing all these operations and to this data set. So at the end, you're still going to get back empty car 1s instead of, you don't have to create a new one. So so this is the same as, like I said, same as this. So again, so all these is just, I mean, make your code a lot cleaner and easy to read, because like I have read a lot of messy code and it's very hard to follow sometimes if they're right, especially if someone did it and then you're trying to, see what they did. If they're messy, it's very hard to follow. But I mean, I'm not saying this is super clean, but I think at least you can follow. Okay, for empty cars, first what I did was I convert the row names into a column. The second thing I did was I filter out all the manual transmission and then convert the time and then select the column and then plot. So it's very easy to follow this way. At least I personally think so. So yeah, I guess that's the pretty much the dplyr package and the magrittr package. Any questions? I guess we're it's time, right? Okay.